Lokhande from Nagpur.
I'm Shashidhar from Calicut.
Yeah. They have given us the biodata. She has handed me over.
Okay. Madam can start, or you?
This is the speaker is who?
Yeah.
I will do some clinical.
Clinical is Prantar ka.
I will do that.
Nidhi Jain is what she is talking about. Yeah, maybe management of PNH also.
Okay, no.
ये है.
The Andhra ka topic may be better for me because more of clinical. Really
Prantar
clinical.
and ये Nidhi Jain.
Okay.
ये जो है.
Madam can take elaborate.
Hello, check.
This is the hemolytic anemia.
First speaker is talking.
People won't come back to the hall. Nobody is there in the hall.
Nobody is there.
तो उनको पूछने पड़ा कि whether we start now. वो बोल रहे हैं और लोग आएंगे तो अभी उनको पूछ लो कि अभी स्टार्ट करें कि
नहीं स्पीकर भी नहीं होंगे शायद.
शशिधर नहीं स्पीकर भी नहीं.
हेलो हेलो हेलो. माइक ऑन नहीं है ना.
कुछ लिखने के
ये ऑन नहीं है.
माइक ऑन करके देख लिखने के लिए कागज दे. पेन एंड पेपर और आई हैव सम.
Shall we wait?
Sorry for the technical glitch. We're starting in another 2 minutes.
2 minutes.
आपको डिसेबल करना पड़ेगा.
हाँ पेन तो है मेरे पास. वो चाहिए आपको तो.
कितना मिनट बोला? 5 मिनट.
नहीं इनको 20 मिनट है मैडम. 15 मिनट का टॉक. 15 मिनट का टॉक फॉलोड बाय 5 मिनट्स क्वेश्चन आंसर.
So I'll just give between us. I'll just give a little background introduction, and immediately we'll
ask him to talk. इसका इनका बायोडेटा आप पढ़ेंगे कि मैं पढ़ूं?
आपको दे.
हाँ ये है.
I'll just tell you.
हाँ अबाउट दैट. हाँ
and under that we have how many speakers? 1, 2, 3, 4.
पैनल
4
डिस्कशन.
speakers and 1 panel discussion. And 4 speakers, I will request them to take exactly 15 minutes and finish it off by 5 minutes. Then I will hand over the mic to you to introduce the speaker.
Okay. 15 minutes. 15 minutes.
10 plus
50. यहाँ पे 15 + 5 लिखा है. 20 मिनट का टाइम है. यहाँ पे 15 + 5 लिखा है.
उनका टाइमिंग
हाँ पूछ लेते हाँ 20 minutes.
नहीं पूछ लेते हैं उनका कुछ.
Is it 20 minutes? Yeah, I have.
It is 15.
20 minutes ना? Talk,
15 minutes talks,
5 minutes question.
minutes
ठीक है,
question answer.
it's okay. ठीक है. आगे shall we start or we wait?
there is some problem in copying the PPTs.
Okay. ठीक.
It was not come or not the.
नहीं वो PPT कॉपी करने में टाइम है अभी. तो
No, we'll schedule panel discussion. We can summarize also. If it is so.
या इट इज
जो भी कर सकते हैं.
मैनेजमेंट पे ही है. सो
So
सर
you can
कर
moderator is Ankur Jain.
हाँ.
So we'll call Ankur to moderate. Then let the present. Then we'll have a question and answer.
Sir, please come on the stage, Dr. Ganesh.
शुरू करें. सीधे. हाँ नहीं वो बोलेंगे ना उसमें. ये कौन है? He wants to. He's the speaker. Very good morning. It is the time for the session, and after the book release celebration and session, we come back to the hemolytic anemia session, where there are 4 speakers and 1 panel discussion. And I would like to request the speakers to stick to the time, that is 15 minutes, and question answer for 5 minutes. So if we stick to the time, we can also finish. There is 1 panel discussion also. Many questions can be taken up during the panel discussion in the last. That also can be done. And this is our pleasure to introduce the speakers. And I also would like to thank the organizers to give us the honor of chairing this session. So on behalf of myself, Dr. Vidya and Dr. Sasidharan, I would like to thank the organizers to give us this opportunity to chair this session. Now we start. Dr. Vidya will introduce the first speaker shortly.
Yeah. Thank you, madam. We have first session, that is quality control in automated hematology analyzers. And Dr. Ganesh Kumar from Department of Hematology, AIMS, would be presenting this lecture. His academic interest revolves around lab automation, rare blood disorders, and genomics. As we all know that hematology has advanced by leaps and bounds during last 2 decades. Sophisticated lab investigations have moved from research to clinical laboratories, like FISH, PCR, flow cytometry, just to name a few. But we all know that we concentrate basically on the patient's clinical history and the basic investigations, and we start with complete blood counts. Hematology analyzers, they give us information about the 5-part or 7-part differential white cell analysis based on electrical impedance, radio frequency, conductivity, light scatter, fluorescent scatter, and cytochemistry, etc. In addition to this, they provide additional information of cell population data, lymphocyte index, glandularity index, and so on and so forth. But what we expect is precision and accuracy, And that is what Ganesh Kumar would be highlighting in his lecture, that is quality control. So to you, Ganesh Kumar, please go ahead.
Thank you, ma'am. Thanks, chairpersons. Thanks, ma'am, for the kind introduction and setting up the stage. At the outset, I would like to thank the organizers for inviting me for this talk. I will be talking on quality control in automated hematology analysis. So what is quality? So ISO, the International Standardization Organization, defines quality as the degree to which a set of inherent characteristics fulfills requirements. That is, it is relative to a set of requirements. To further elaborate this, it is a state of being free from defects, deficiencies, and variations by being strict and consistent otherness to measurable and verifiable standards to achieve uniformity that satisfies specific user outputs. So there are three terms which are related: the quality management, quality assurance, and quality control. So quality management is an all-encompassing term which establishes quality policies and objectives and the processes to achieve these objectives. So it is done through quality planning, assurance, control, and quality improvement. So quality assurance refers to that part of quality management which provides confidence that the quality requirements will be fulfilled. This is done through adequate control of post and pre and post analytical stages and standardization of procedures and instrumentation. Quality control per se, mainly it pertains to the assay which is run to verify the tests are run correctly. It is the part of quality management focused on fulfilling the quality requirements. The laboratory quality management system essentials as defined by CLSI mentions 12 broad domains, of which process control is the central one to our talk. So process control is one which defines factors important in ensuring the quality of the laboratory testing procedures. This include the quality control for testing, the sample management, collection and handling, as well as the method verification and validation. So how does a lab set about setting up a QC program? So it needs to first establish quality policies and procedures, assign responsibility for monitoring and reviewing, and train the staff in the quality policies, select appropriate QC material as per the instrument and the quality policies, establish control ranges, and make graphs for visualization of the quality data. And then after that, establish a system for monitoring the control values, and if there are any corrective actions needed, that needs to be taken, and a proper maintenance of QC records. So this is the broad steps involved in setting up a QC program. So what are the organizations involved in standardization? There are a lot of organizations involved, those pertaining to hematology, or a few of them are highlighted here. These are organizations which sets up standards like ISO, which are accrediting agencies like NABL, and those agencies which provide guidelines. So this is the manual of the CLSA, the Clinical Laboratory Standard Institutes. ICHS provides guidelines for setting up and initial analysis of blood cell analysis, and the NABL, the National Accreditation Board for Laboratories, is the accrediting agency in India, which accredits medical as well as other laboratories. So the quality control strictly refers to the analytical phase, but it's important to understand that the quality control also encompasses the pre-examination and post-examination, and we need to take this holistic view to provide a proper quality management system. What is quality control per se? It is a component of process control and an essential element of the quality management system. It monitors the process related to the testing or the analytical phase of testing. So the goal is to detect, evaluate, and correct errors due to various conditions, so that it gives confidence that the test results are accurate and reliable. And different QC processes are applied to monitor the quantitative, qualitative, or semi-quantitative tests. So broadly speaking, the quality control can be divided into two parts: internal quality control and the external quality control. The term proficiency testing is also used to refer to that. And how do we do the internal quality control? So there are different ways of doing it. The most commonly used one is the use of control materials and tracking the control data using control charts. There are other methods apart from using the control material, like duplicate testing, patient data, etc., which we'll be seeing in the subsequent slides. So a few words on the different types of control material. So control material itself can be of three types: the reference standards, which are basically held with very few organizations like the WHO, and they are in limited limited quantity, so they are not available commercially to all vendors. So based on that, the calibrators or the secondary standards are made, which are commercially available in the market and which are distributed to the individual labs by the vendors. And the third is the control, which can be either commercial or lab made and which are used on a daily basis. Though lab made controls can be made, it's highly recommended to use commercial controls. So with respect to the hematology analysis, what's the number of controls that should be used? So ideally 3 controls are recommended. One which has a normal value, low value and a high value. So this provides us higher accuracy, and there are specific Westcott rules when there are more than 2 controls. But in rare circumstances because of cost constraints, if the number of controls have to be cut down, if it has to be 1 control, then it should be a normal control. And if it's 2 control, then it's usually the normal control and the low control. So in our department, we have Siemens Advia 2120 and Sysmex XN 2000 systems. So in the Siemens, we use 3 level control, a normal control and 2 abnormal level controls. And in the Sysmex XN platforms, we use level 1, 2, 3 controls. So one is the normal control and low and high controls. So how do you make use of the data from the quality control? So once we decide on the appropriate quality control material, this is usually from the manufacturer of the equipment, though third-party controls can also be used. So once we get the decide on the quality material, we need to establish acceptable reference ranges. So for that, we need to collect at least 20 data points. More is recommended. This should be done over a period of 20-30 days. And the normal variations which are accepted, that is the different types of technicians, the tests run during the different times of the day, like day, night, etc. These all should be incorporated into the, while collecting the data for the QC material, so that it reflects the normal variations in the lab. So then we calculate the mean and standard deviation. A few words about this data points. So 20 data points are required to quantify the normal variation, and it needs to be noted that if there are any solitary outlier, that outlier needs to be left out while calculating the mean and standard deviation. If there are more than 2 outliers, then we need to discard the data set and acquire a new data set. So the most commonly used chart is the Levy-Jennings chart. Here we have a mean, and then we plot the plus and minus 2 standard deviation. So it is a very commonly used method of tracking or plotting the quality control data, and it's fairly simple and straightforward, and most of the equipments have inbuilt programs to track the QC data using LG charts. So here, once we have made the mean plus and plotted plus and minus 3ST, we can track the daily data of the QC. So this is the LG chart from the 2 of our equipments, the Sysmex and the Siemens, and you can see each parameter has a mean and as well as the plus minus 2 ST, and then the daily data is tracked. And this is for each level control, level 1, level 2 and level 3. A few words about precision and accuracy. So accuracy is the closeness of the measurement to its true value. Precision is the amount of variation in these measurements. So this one is a measurement which is both precise and accurate, and this is precise but not accurate because it is away from the true value. So when do we say the QC data is in control or out of control? So when we are running the QC daily and then we plot it on the LJ chart, if the value lies within the plus minus 2 ST, it can be accepted as in control, and it is out of control, then it is out of control or an error. So it's important to remember at this time, so though we mainly concentrate in this talk on the quality and the analytical phase, because this is a quality control talk, the majority of the errors in the clinical laboratories are actually pre-analytical errors, which account for up to 40 to 60%, followed by post-analytical errors, which are up to 25 to 45%. And when taken as a whole, the analytical phase is only 7 to 13% contribution to errors. So it's important to look at those aspects also. So the errors can be random or systematic. The random errors are usually not a problem when the machine, the QC is rerun, usually it corrects. And systematic errors needs to be taken into account, and the root cause has to be found because that usually indicates some failure in the system. So this can be either a shift or a trend. Leveraging charts are very useful in tracking the shifts and trends. So what is a shift? It is basically the data is lying on the one side of the mean. Usually we expect the data should be scattered around the mean. So if there are more than 6 data on one side of the mean, then it usually indicates a shift. There is a shift towards the new mean. Whereas trend is something in which the movement of the QC data towards one direction. So it usually starts on one side of the mean, crosses the mean, and then it goes on towards the other side of the mean. So both shifts and trends are systematic errors and needs to be corrected. So Westcard biochemist has proposed multiple set of multiple rules. So they can be used when more than 2 controls are used. So when you follow the Westcard rules, the first 2S is one where the QC, if there is no error, then the QC, the test can be reported. If there is one quality control data falls out of one standard deviation, then we have to follow the flow chart for the QC results. So it gives about 6 or even more type of violations which needs to be taken into account. So this is the one where there is one 3S rule violation. There is one data falling outside the 3 standard deviation. So this run should be rejected. If there are 2 runs which are outside the 2 standard deviation, then the results have to be rejected. So this is the 4 1S rules violation where they are 4 consecutive values are falling behind one standard deviation. So this comprehensive set of rules are quite helpful in tracking the QC data and accepting the error as in accepting the data as in control or tracking out of control data. So Six Sigma metrics has lately been used, increasingly being used. It is mainly derived from the engineering QC idea. So here we calculate the bias, the CV, and the total allowable error, and the when we get the typical 6 sigma, then the defects are only 3.4 per million. So it's 99.9% yield. So what are the other data, other quality control techniques apart from use of quality control? So we can use duplicate patient testing, where the difference between the pairs of results are calculated and the SD is derived. And these methods will help to detect random errors, but it did not detect incorrect calibration. So other methods can be used, like the use of red cell indices. So the red cell indices is a fairly stable parameter, and when we take the means of a large number of values, like at least 100, then over time the mean should remain constant. So if there is any shift or deviation from the mean, that indicates a problem in the machine. And the procedure by Bull basically takes the absolute values of this MCV, MCH, and MCHC parameters and derives the quality control data based on the differences in the means of this data. So the other simpler ways of doing is the correlation check, where the results of any abnormal report from a CBC can be checked by means of simple procedure like a peripheral smear examination to see if the results on the peripheral smear correlates with the CBC values. Other is the delta check. So if the condition of the patient has not changed much, then the report of the patient should not be significantly different from the previous values. If there is any discrepant value which without any apparent clinical relation, then this must be rechecked. So what to do if QC comes out of control? So the testing should be stopped, and then the cause or the root cause of the error should be identified. If the error is identified, then uncorrected, then the control material should be rerun, and then the testing has to be restarted. So there are different types of troubleshooting. Then the problem can be with the quality material itself, it can be with the machine, or it can be with the reagents, and this needs to be sorted out. A few words about instrument verification. So this parameters, the previous quality control or the routine quality control runs with each sample, but when the machine is run, when the machine is established for the first time, we need to establish few additional parameters like comparability, linearity, analytical sensitivity, and reference ranges, carryover, etc. And this needs to be done when the machine is due for calibration every year. A few words about the EQA program or the proficiency testing. So we participate. It's highly recommended to participate in a EQAS program. So we participate in the UK EQAS program. So we get 2 monthly samples, where we get a sample for 2 samples for CBC, where we give the WBC, platelet count, and the hemoglobin, and we we get 2 slides for morphology, and we need to give the differential along with the possible diagnosis, and 2 slides for parasites. And the results are provided in the form of the deviation index, where the median of the group is given and our results are provided alongside, and the deviation index is calculated. So anything, the deviation index between plus minus 3 is acceptable. So though if it's closer to 0, then it's ideal, but anything plus minus till plus minus 3 is accepted, and beyond plus or minus 3 indicates an
Ganesh,
outlier.
you have to shorten it.
Sure, ma'am, I'll go ahead.
Time.
So the UK NECOS is a very good program where they give a good feedback, not just for the individual lab, but also for the whole group. And apart from that, they give expert comments by Professor Barbara Bain, Patterson, etc. And AIMS in partnership, the Department of Hematology at AIMS in partnership with ISHTIM runs the External Quality Assurance Program. And it's a large program with more than 6,000 participants throughout India. So we provide samples for CBC, PS, and reticulocyte count. And the samples are sent in 3 monthly intervals, 4 cycles per year. And the assessment of the participant performance can be done by different methods. We follow the Z-score, which is similar to the deviation index. This is the results from one of the participants, where with the within group consensus as well as the within lab precision is also given. So this is the contact for our EQUEST program, and these are the few references. And I would like to acknowledge my senior and my colleagues at the Department of Hematology at AIMS and Pgi-Hem-Onc, and I will stop here and take any questions.
Thank you, Dr. Ganesh. I think it's open for discussion. Questions, please, from the floor. No questions. I have one comment, rather a question, that how often you run these 3 controls, 12 hourly or 24 hour?
Yeah, that's a very good question, and I think, the same criteria may not fit all labs. So the minimum recommendation is we run at least once daily, but that is for a lab which is a day lab, which is from 9 to 5. But I think if it's a 24-hour lab, then it's recommended to run more, at least twice for each shift, or in fact even more. But at least once per day for every lab, and if it's a 24-hour, probably twice.
And you run all these 3 samples?
Yes, ma'am. We run all 3 controls. So our lab is from 9 to 5. We have a separate emergency lab. So in our department.
What is the standard deviation in that?
Ma'am, so by and large our reports, our QC points fall within the plus minus 2 ST, but we do get problems with outliers. Then we usually do the routine cleaning procedures, and most of the times it gets it's usually a block in the tubings or etc. So but rarely we get into larger points. So mostly the results are within limits, and then if there is a problem, usually the background, the flushing and cleaning should work for most of the times.
Dr. Dasgupta, please.
Yeah. Just a small comment. I thought you said that if you are running 2 controls per shift, you would run a normal and a low. That's what you mentioned.
No, sir. So
standard practice is to run the high control, not the low.
So basically, I mentioned with.
Clarify this.
So I thought with each run, it's better to run 3 controls, all the 3, ideally, yes. So in our practice, in each day we run all the 3 controls, the low, high, normal, low and high controls.
Any other comment or question? No? Okay. Thank you, Dr. Ganesh.
Thank you.
The next speaker is Dr. Diksha Yadav. She is from Department of Hematopathology Lab Services, Gurugram. Her areas of academic interest are hemoglobin disorders, hemato-oncology, flow cytometry and genomics. and she's going to deliver her lecture on hemoglobinopathy diagnosis, current updates.
Just give me a second. We are locating my PPT.
Yeah, hemoglobin disorders, they require knowledge of genetics, precise diagnostic tests that are required, when to request sophisticated tests and how to interpret the results. Another important thing is sometimes hemoglobin variants will require unequivocal identification by DNA technology or protein analysis.
Are you ready?
Are you ready?
Yes, ma'am.
Okay, you can go ahead.
Thank you, chairpersons. At the outset, I would like to thank my dear teachers for giving me this opportunity. The topic for my talk is hemoglobinopathy diagnosis, current updates. This is a brief outline of the talk. They say all science is a work of art, and this indeed was a masterpiece which took 25 years to complete, and the artist was Professor Max, who was later awarded a Nobel Prize for discovering the structure of hemoglobin. If we talk about the timeline of hemoglobinopathy research, keeping sickle cell anemia as the poster child, in 1910, Herrick first discovered these peculiar-looking cells. In 1949, Linus Pauling established sickle cell anemia as the molecular disease, and subsequently, many notable advances have been made in the field. Fast forward to 2022, where FDA has approved first cell-based gene therapy in beta thalassemia. So hemoglobin disorders can be quantitative or qualitative and are largely divided into thalassemias, hemoglobinopathies, and thalassaemic hemoglobinopathies. Because before moving further, I would like to first discuss about the most commonly used traditional approach to test hemoglobin variants. In the first line, we employ complete blood count, peripheral blood examination, and reticulocyte estimation, followed by HB-HPLC, electrophoresis, and some ancillary tests like sickling or HPH preparations, and finally molecular methods, which could be gel-based PCR methods or Sanger sequencing. Now one might ask, if we have such a standard approach, why do we require novel methods? Well, the answer is limitations. Each of these unique tests have their own limitations, the general theme being that they are relatively less sensitive and specific, they are time-consuming and labor-intensive, and even after doing the whole gamut of tests, there are times when the diagnosis is still amiss. So the novel testing method quest started with the aim in mind that we want a test that is fast and accurate, has a higher throughput, is less labor-intensive, affordable, and gives a multi-dimensional information, quite a mouthful actually. In this quest, we first encountered next-generation sequencing, and for a while it seemed like a eureka moment because it had very many advantages over traditional Sanger sequencing, most importantly being it was a high-throughput technique and gave a global assessment of genome at one go. However, the enthusiasm in the hemoglobinopathy arena was not as same as in oncology, because at the time, this was an imperfect technique which did not detect all aberrations encountered in hemoglobin variants. However, with time, this has changed. So the next quest was third-generation sequencing, and it seemed like a one-stop solution with its long reads, no PCR bias, minimal library preparation, its capability to give us multi-dimensional analysis, and a faster TAT. And there are 3 platforms in third-generation sequencing coming on to single-molecule real-time SIT technology by PacBio. This uses zero-mode waveguides and terminal phosphate link fluorophores. In this, the DNA molecule along with DNA polymerase is immobilized at the bottom of the zero-mode waveguide. Reagents are poured in, and as the reaction proceeds, laser light excites the fluorophore while incorporation, and fluorescent signals are measured in real time. Moving on to Oxford nanopore technology, it uses nanopores that are inserted in the electrically resistant polymer membrane, and under control of this motor protein, the nucleic acid molecule is unwound and is ratcheted through this nanopore across a voltage difference. This creates a characteristic current change which is measured in real time. Moving on to a very recent technology, which is synthetic long-read sequencing. Now, this got me excited because this is a computational and processing hack and does not require an additional hardware or a machine. So in this, the DNA is first segmented, enzymatic landmarking is done, and finally, synthetic long reads are prepared by using marked and unmarked short reads. If we compare the three techniques in third generation sequencing, two things pop up. First is cost and second is error rate. Traditionally, we know that single molecule real-time sequencing and Oxford Nanopore have very high error rates. But with time, these two have improved upon and now have an accuracy of 99.9%. Synthetic long reads, however, is a very new thing, but it claims high accuracy and has an added advantage that it does not require an additional instrument and is compatible with the available NovaSeqs. Let's take a few examples. In this study, the authors have demonstrated the superiority of NGS vis-a-vis traditional methods in a cohort of 951 patients. This is another study which claims that Oxford Nanopore showed 100% concordance with the previously known genotype. So third generation and next generation sequencing are mostly important in cases where we are suspecting a trans-acting gene or a syndrome where there is contiguous gene loss or complex genotype-phenotype correlations are to be made. In the year 2020-22, Nature Methods regarded long-read sequencing as the method of the year, primarily due to its contribution in telomere-to-telomere sequencing. However, in diagnostic arenas, cost and turnaround time are major obstacles. As a rebuttal to turnaround time, Stanford cardiologist Yuan Ashley has registered a Guinness World Record to sequence full human genome in just over 5 hours. And as a rebuttal to the cost, Ultima Genomics has come up with its innovative open flow cell on a rotatory platform with a non-terminating chemistry coupled with machine learning algorithms, and they claim that they will give full genome sequencing at the cost of $100. So a lot to look forward to in the world of genomics. Moving on to mass spectrometry, this is another very powerful technique which is used to identify and quantify chemical composition of substances based on mass to charge ratio. This is done in 5 steps. First, the sample is vaporized and then ionized with electron beam, and these ionized particles are then accelerated through electrical plates, put in a magnetic field, deflected, and then finally detected. And that output looks like this. We get relative intensity or relative abundances along with mass to charge ratio. This mass spectrometry can be done by 2 approaches, bottoms up or top down approach. In the context of hemoglobinopathy diagnosis, top down approach is preferred because it is fast, requires minimal sample prep, and does a better variant characterization. However, both these techniques require the presence of comprehensive databases. In the study, the authors have done a head-to-head comparison with high-resolution mass spectrometry and HPLC in a large cohort of over 5,000 samples. And the results have fairly been concordant, with the exception of 3 cases in which Sanger sequencing confirmed the findings of mass spectrometry. And this proves the utility of the technique. This was another study which proposed the use of abundance ratio between delta and beta subunits for beta thalassemia screening and touted as a candidate biomarker. Coming on to non-invasive perinatal testing using cell-free fetal DNA, we know that in 2010, Dennis Lowe in his landmark paper first established that size-based separation of fetal DNA from maternal plasma was possible, and he also explained its nucleosomal nature. The success of non-invasive prenatal testing depends upon fetal fraction and depth of sequencing. There are 2 major concepts for denoting fetal genotype: relative mutation dosage and relative haplotype dosage. In this paper, this was an interesting paper in which authors used droplet digital PCR instead of NGS to analyze cell-free fetal DNA, and the results were quite exciting. This is another paper which circumvents the problem of additional testing in family members for construction of parental haplotypes. In this, they used a 1,000 genome project and a local haplotypes data set and incorporated that into a software to generate parental haplotypes. Coming on to point of care testing, loop-mediated isothermal amplification became quite popular during COVID times as it requires no thermocycler or post-amplification processing. In the study, the authors have developed a colorimetric gap lamp which can be used for screening of alpha thalassemia in large populations. And in the study, they showed 100% concordance with the conventional gap PCR in a cohort of 410 individuals. So in the world where we have an app for everything, hematology is not far behind. This US-based study has created a smartphone app which will take pictures of your nail beds and on the basis of the color will determine the degree of anemia. Similar applications have also been tested in India. Coming on to the role of artificial intelligence, it is coming in a big way, and I guess we all have heard of the buzzword ChatGPT. In context of hemoglobinopathies, there are a plethora of purposes where artificial intelligence can be used, such as genetic profiling, drug discovery, creation of digital twins, in silico drug trials, etc. Artificial intelligence can be predictive, generative, or conversational. If we talk about predictive AI, digital twin is one good example of it. A digital twin means creating a virtual replica of an object or a process or even a human being. And this requires amalgamation of physical, dietary, metabolic, genomic, pharmacogenomic, health record, and sensor data to predict behavior of genetic alterations or disease biology in an individual, and in the future might aid in personalized treatment. As we all know, it took 30 years to decipher the structure of hemoglobin, so we know that predicting protein structures has always been a challenge, and it takes years to comprehend. But with newer AI methods, this is achievable in minutes. And this can be utilized to triage and circumvent functional study in cases of novel mutations or variants of undetermined significance. Moving on to conversational AI, we have all heard of Siri and Alexa. It's time we heard of Rosa and many such other AI conversational agents which are now being used to educate patients and their relatives regarding the intended diseases and allay their anxiety, simultaneously relieving the healthcare providers for other priority works. To conclude, we are witnessing a transition in diagnostics to a data-intensive approaches and methods with more and more dependence on comprehensive databases, bioinformatic pipelines, machine learning, and artificial intelligence. This will help us deliver all-round multidimensional information and will lead to better and improved healthcare experience. And the hope is to develop indigenous, innovative technological solutions to deter and detect disease-causing aberrations and offer personalized treatment in hemoglobinopathy diagnosis. Thank you.
For nicely describing all the methods now available in this hemoglobinopathy area for investigating these cases. My question is that what do you think about recommending in India, in all the hospitals, which methods should be followed?
Ma'am, it depends on what setting we are. If we are in a setting where we have already established our basic PCR, like the traditional approach which I had first described of CBC, HPLC, and molecular methods along with Sanger, which is a very good technique and solves most of our problems many a times. The only concern there is time. Because it is an algorithmic approach and it will take time to finally arrive at the diagnosis. So everything is important in the context of time, the money, the infrastructure, the kind of tests we have already validated in our setup, and the instruments we have. On the basis of that, we can make a call.
Now it is open for discussion. I think some comments also.
I think Diksha, you took a very nice talk, and I would just like to say that recently we know that NGS is not a very good technique for hemoglobinopathies because all the globin genes have so much of similarity between each other. But there is a kit which has come up, and this kit is it includes all the point mutations, all the kinds of deletions, both the alpha globin genes, beta globin genes, alpha 1, alpha 2, delta, everything included. And we kind of just validated that kit, and it appears to be pretty good. So you just need a sequencer, you just need a DNA sequencer for that. So it combines the work of MLPA and all those things and all the common mutations. So we thought that that seems to be a good kit if one can afford to buy that kit. It's not very expensive compared to the NGS kind of. They have kind of looked into the small details where the problems are there for hemoglobinopathy diagnosis for because of these sequences which are very common between the different globins.
A very nice presentation.
Thank
I
you,
think you have
Yes,
shared a lot of
Dr.
information which is on the horizon. I mean, a lot of it is not, of course, being implemented in
Yes.
most of the labs in India, but to know about them is also very important so that you can therefore look forward to introducing them when the actual time comes. My question was more coming back to the ground level, where it's my observation, we also do a good amount of HPLCs in hemoglobin, suspected hemoglobinopathies, is the incidence of biphase hemoglobin A2 peaks, which are difficult to measure. They are normally reflected as close to 0 or 0% in the HPLC. And we tend to label them as maybe hemoglobin Saurashtra, which is reported in India. So what is the experience of others also? I would like to hear from you. Have these been characterized in larger centers, and unlike what is the belief that hemoglobin Saurashtra is not that common?
Yes.
Looks like it is not so uncommon. And I was talking to Roshan, and she also believes, Roshan Kola is, of course, has done a lot of work in this area.
Sir,
so
if
I would
I'm-
like to hear from even others, if hemoglobin Saurashtra, which is a practical problem,
Yes.
is indeed a problem, or these are all fallacious things.
So which platform are you talking
hemoglobin A2
about?
Prime also.
Sir, are you talking about D10 or beta 2 variant?
No, I'm talking about variant.
Right. Recently, we have encountered a similar case. Recently, we encountered the very same case, and I was in the similar dilemma as you, but we had the D10. And in that case, we went back, took the history, did family screening, and at the end, it turned out we just watched the RBCs and ran it again, and it just vanished.
Dr. Ghosh, can you please use the mic?
Structures of hemoglobin A2. That is not going to go away by washing the RBC.
Sir, if we have proved that it is Saurashtra, then the problem is solved. But if we have just done the HPLC.
He is not asking that.
Yes,
He's
sir.
asking,
Sorry, I didn't get your question
He is asking,
then.
do you have any experience of knowing how many hemoglobin Saurashtras you have got?
No, I'm sorry.
See, this was a study done by us only in hemoglobin Saurashtra from National Institute of Immunohematology. And we got majority of the samples from some part of Gujarat. So that's why it was named.
Sure.
Like it was Saurashtra. And as Dr. Dasgupta is telling that this kind of, it may not be only hemoglobin Saurashtra.
Sure.
So
sure.
basically you expect the variants of delta hemoglobin is possible.
Yes.
So ultimately it is delta hemoglobin sequencing.
Yes.
Yes.
So question is we have to develop an algorithm in which we have to put when we have to do the delta hemoglobin sequencing and to tell. See, previously also with the standard variant 2, when we were doing the sickle, you are having a problem with the A2 area. That is because of the unevenness of the
Baseline.
baselines. So we were having a problem with
Yes.
that. and many of the hemoglobins which are little bit not so stable, if they are not kept properly, they also will give you many peaks.
Yes.
So that is what it is there. In the ground level, we are not going to do all these hi-fi instruments for
Sure.
foreseeable future
Yes.
when it comes. So the one which we are using, as you have said, we are using for sickle cell anemia, Dr. Mohanty has written, I am also a co-author of that paper, that is using the monoclonal antibodies against various common hemoglobinopathies.
Yes.
There are two things. One is patient, another is community, another is control, not eradication. So basically, when you are in community and control, there is more problem on common hemoglobinopathies and of detecting common variants.
Yes.
And they can be done with most of the time with available kind of means.
Yes, sir.
And because the two alpha and beta, two globin genes, they are the open reading frames are not very big.
Yes.
They are some 170, 140 amino
46,
acids.
147.
So sequencing them in a routine
It's very
sequencer
easy.
is not a problem.
Yes.
Problem comes in the intervening areas of the gene where many of the thalassemic hemoglobinopathies problems are located.
Yes.
So then the gene becomes big. And
I
the problem-
absolutely agree, sir.
I think, Diksha,
Yes,
I would like to tell everybody that it depends upon that which situation you are. For clinical practice, sometimes you need the point of care. And sickling test is a very simple test,
Yes.
which is still available in many of the places and also very valid.
Yes.
Second is we have to develop some point of care where it is necessary. Second, as Dr. Ghosh has already told, there will be some which will need some DNA and other method of proving it.
Yes.
So it is like that. When you go to community, it will be a different approach.
Yes, ma'am.
When you are in the hospital, it will be a different approach. And also in the emergency, you have to use another.
Yes.
So, because many of these variants are not of much clinical importance also. So, it all depends upon what you decide in your practice.
Yes, ma'am.
Thank you. With this, I think,
Thank you.
if anybody else has got, yes, please.
Just to add a practical point to the A2 thing, which of course Diksha knows well,
Can you
if
use
your
the
HPLC is including the, if the HPLC is including both the A2 peaks in the quantitation, then you don't have to worry because we're only using A2 for diagnosing beta-thal trait. The problem happens if there's another peak close by, in which case, as has already been said, sequencing of delta HBD is a pain. It's, at least in our center, it's very difficult to get that. So A2 prime we read about in books. I have yet to see my first case. It should be coming in the sickle window. So that's where we stand as far as the two peaks go.
Why A2 I raised the point of A2 Saurashtra is that we have worked with the NIH group, and we have seen that when you have interplay of beta thalassemia with hemoglobin A2 Saurashtra,
Yes.
the diagnosis becomes very difficult. These are
Yes.
like, they're not
Underestimation of
expressed
A2. Yes,
yeah.
yes.
And second point which Dr. Mohanty made, I would like to emphasize that, and again I'm saying from experience, is that many of the not so significant hemoglobinopathies appear in the HBS window. And it's my experience, we have reported 3 or 4 variants where the simple tests are sickling. All of these cases were sickling negative.
Yes.
So when you see a peak in the sickle window and sickling is negative, that is when you should go ahead and do this thing. Otherwise, sickling, you don't do molecular studies. I mean, we advise for sake of being correct, politically or otherwise, but it is not required there.
Yes, sir.
But in these cases, the sickling is sickling is a very important test. On one side, it's a very simple test. We should do it together.
I think we are running short. We can talk later.
Sickling is so important. Last week only we had a patient with anemia, and peak in the S window. Someone had reported the patient as sickle. We did the sickling was negative, and it turned out to be a hemoglobin rush patient. Rare, I think it's the second case, first one has been reported from PGI. We just picked it up last week. So doing a simple test like sickling is very, very important.
Yes.
We just can't put it in the background.
Yes.
Thank you.
I absolutely
Thank you very much.
agree with all of the valuable comments. The topic's title was recent updates, so yeah.
No
Thank you so much.
You have done a very good job. I think you will introduce.
We will go to the next speaker. The topic is the topic is advances in management of hemoglobinopathies and sickle cell disorders ahead. The speaker is Dr. Pranta Chakravarti, consultant hematologist, Soho Corporation, Chennai. I hope he will explain what this Soho Corporation is all about. He is a hematologist with a difference. He is trying to reach out to the community to address social issues, which is absolutely essential as doctors interested in the social aspects. Over to Dr. Pranta Chakravarti. His areas of interest are hemoglobinopathies, community hematology, artificial intelligence, and design thinking. Thank you.
So, yeah, thank you. So, task ahead for India is something different which is closer to my heart. But anyway, first we will look at the technology, and all of the people here know that, thalassemia itself is an entire spectrum and there is no watertight compartment there. So managing it is more of a clinical challenge rather than using tools. Now, if you have to see where you would like to target it, in beta thalassemia per se, without any connotations, you have chronic hemolysis, you have inactive erythropoiesis, you have iron overload, and ultimately all this lead to multi-organ damage. At the same time, if you look at sickle cell disease, two other things come up. One is the sickling per se, the polymerization and all its, the inflammatory component there, and vaso-occlusive crisis, which ultimately lead to more disasters. So on this background, what we are trying to do, suppose to tackle beta thalassemia, is we are trying, and in some literature now it says it's palliation, though I don't think it's agreeable, because we are keeping the person alive with a good quality of life, but it's blood transfusion, which should be safe and optimum, not running after numbers, iron chelation, splenectomy in certain groups. I'll not go into when to do and not. And then there's something called supportive care, where actually we are trying to target ineffective erythropoiesis along with disordered, and two of the molecules which we are using, one has more evidence, the other is more into investigator-initiated trials, like hydroxyurea and thalidomide, and then we give calcium, vitamin D, folate. We do not forget to vaccinate. And then obviously the only curative option for most of the world even today is an allogenic stem cell transplant. There have been advances there in terms of data from even haploidentical. I'll not go into those details. Let me take up blood transfusion first. I think even there, comprehensive patient genotypes and using information technology to keep it for this group of patients is very important. And you can have multiplex PCR, so you get less and less of reactions. You're also trying to get rid of transfusion transmitted infections, but obviously unknown infections will be there. They will remain a challenge. The two new things which have happened are, and they are in clinical trial, one is in phase 4 as I show you, is leuko-reduced packed RBCs with RBC transfusion, some sorts of newer techniques, and one is oxygen reduction system, HemaNext, which is a hypoxic RBC storage where you anaerobically store these RBCs and reduce the levels of markers of inflammation and hypoxia. So the DPG delivery is better. And as you all know, we have now started again trying to make artificial blood. Now, what is there in the iron chelation? We have 3 molecules, of which 2 we are using orally. There is a new kid in the block, but I am seeing this kid almost for the last 5 to 7 years. It is a small molecule called SP420. Phase 1 safety has been done. It's there on the company's website, not much in the public domain. And this design was shared, it's there, the NCT 02274233. But the results of this are still not available. It is supposed to be more efficient and it is supposed to have less side effects, but I cannot tell you anything unless I look at phase 3 data. The other molecule, which was once upon a time said to be quite efficient, trials have been stopped because later on we came to know it was causing renal cell carcinoma in mouse models. So ferritin is out. Now targeting anemia, right? So thalidomide, most of us have some experience, but we do agree that we still do not know how to efficiently use it. We have published certain comparisons with hydroxyurea. There are even studies published combining hydroxyurea and thalidomide. But basically, it has its own side effects, and we have to identify the people who will benefit most. Now, coming to others in phase 2 trials, I'll show you how we are approaching it. So there are hepcidin analogs, there are TMPRSS inhibitors. There is even Yuzhu Shengzhu granule, which can reduce anemia. Sirolimus is being tried. The only one which has been now approved by FDA and available in India at a very high cost again is luspatercept, both in TDT and NTDT, and there is mitavitat. Okay, that also is still in phase 3. So, as I told you, if you want to target ineffective erythropoiesis, what do you use? For a long time we have used erythropoietin, and in certain studies, not very effective. For hemoglobin F induction, we have used 5-azacitidine, decitabine, hydroxyurea we are using, and butyrate derivatives. Now there are certain oral derivatives which are in clinical trial. You'd be surprised to know that, again, JAK2 inhibitors are being tried. Phase 2 studies are already over. It not only tackles the problem of splenomegaly, but it seems also to convert ineffective to effective erythropoiesis. But still, the proof would be in the pudding when we get it. Activin 2 receptor traps, that is sotatercept and luspatercept. These are what TGF-beta controlling erythropoiesis, and there is another group of agents which target the Forkhead box class O3. Now, why is this important? Because our age-old friend metformin seems to act through this pathway. So there are trials of metformin in thalassemia. Now, targeting iron dysregulation, other than iron chelation, hepcidin. So obviously, this has been there for 15 years. Analogs have been created. We have small molecules which are hepcidin agonists. And as I told you, one of the molecules in that clinical trial scenario was TMPRSS6 inhibitor, which increases the hepatic synthesis of hepcidin. So ultimately, that disordered iron regulation. We have even tried giving exogenous transferrin. It has not been very successful. We have tried to inhibit the erythroferron, which is the total milieu where we can tackle the iron dysregulation. Now, I'll discuss, I think, about 1 minute for luspatercept, because stress versus ineffective erythropoiesis has shown certain changes. And here, as you can see, there is also hyperactivation of JAK2 kinase. So that's why probably JAK2 came into the picture. And there are certain controls over erythroid lineage development, and TGF-beta superfamily ligands are in the differentiation maturation stage. So these are some of the players which are doing it. Even rapamycin as an mTOR inhibitor, I talked of FOXO3, other than metformin, There is resveratrol, not very promising results. Exogenous transferrin, I told you, it has not started its phase 1, and erythroferon. So there are people who are trying it. Now if I come to luspatercept per se, what it does is it's basically a chimeric antibody. One part is the extracellular part of R2A, which is sotatercept, or R2B is luspatercept, and you have FC part of IgG. It goes in and it tries to differentiate the erythrocytes. But if you look at the trial results, and I'll show you some of them, you'll think that, it should act in everybody, but it does not act in most of the persons. So this is from the beloved trial. This was in NTDT, and you will see once every 3 weeks for 48 weeks, started at 1 milligram per kg, reduction in the event of toxicity or excessive hemoglobin increase. Erythroid response was there, but nothing to talk home about except possibly people who need sometimes and who don't want to take blood transfusion. Now if I look at TGT, this has been a recent review article because I think the industry and the key opinion leaders also felt that people were getting thoroughly confused when you look at the indications. So they feel, and there is no hardcore evidence here, because EMEA, when it has approved luspatercept, has said that you will wait for maximum of 15 weeks. If it doesn't reduce the frequency, you stop it. Now they feel that, like Musallam and Sujit Seth and others, that it should be continued for longer. So they have given these priority groups where actually those who receive less than 4 PRBCs per month, who have a non-beta 0 with a beta 0 genotype, not both beta zeros, and if there is shortage of blood or there is scheduling or travel challenges, progressive iron overload. So all these are very subjective issues. So you can read this article. Frankly speaking, because of cost issues, I have never used this molecule. If others have used it, they can share their experience. Now, other than the conventional therapies, which are allogenic transplant, including, as I told you, hemoglobin F induction, the possibilities are in gene and cell therapy, obviously, as you saw in the diagnostic part also, and certain nanotherapies. So before going to gene therapy, where I'll discuss both the diseases together, let us look at SCD. And you saw this, that from 1910 and in the last 10 years, you have seen crizanlizumab being approved, you have seen voxelotor, and then you see crizanlizumab not being able to achieve the end outcome, and it has already been withdrawn from Europe. So basically, there are 4 drugs which are approved: hydroxyurea, L-glutamine, and crizanlizumab, not in Europe, withdrawn, and voxelotor. Other than that, we are trying to increase the fetal hemoglobin through gene therapy again, suppressing BCL11A, simulate HPFH variants. But we should remember that hydroxyurea acts well, and so it should be used. You can target adhesion between cells, feedback loop, and other inflammasomes. So there are a number of molecules there. You can see like Rivipansel. Again, it has failed to achieve the end outcome. Rigadenosone, phase 2 completed, and canakinumab. I'm not going into the cost factor. Science-wise also, they have not proven to be game changers. So there have been hits and misses there. There is one molecule where the trial will also be held in India, fortunately, is this molecule, Itavupat. It's an oral pyruvate kinase activator in red blood cells. It acts both in sickle and in thalassemia, and you will hear more about it. So I'll need 3 minutes for what is actually very promising. If you know what happens in the genetic basis, there are 2 components. One is gene therapy, where you put in a corrected gene through vectors, mostly lentiviral vectors, and the other is you edit the gene. So as was mentioned, Zynteglo has been approved at a cost of $2.8 million, that is 32 crores per dose, okay? And this is the data which was published in New England Journal. it acted in most of the patients, so sustained the new hemoglobin A level. Most patients, again, with non-beta 0, beta 0 genotype, including those younger than 12 years, how long it will be sustained, you'll come to know later. But what is gene editing? Gene editing is either you manipulate the RNA, you can use antisense oligonucleotides, which may be AMOs or SSOs, but then you need frequent injections, and I'll explain to you why. You can put in short nuclear RNAs through vectors, which can then augment the system on a long-term basis. And you can manipulate the genome using nucleases. And here you had first meganucleases, then you had zinc finger nucleases, talents, but the flavor of the season is obviously CRISPR, Cas9, Cas12a, where certain trials are also being held in India. But the problem with nucleases is that you are doing the homology using protein interaction, achieving double-strand breaks, and getting the repair. So there is a lot of off-target toxicities. If you want to get rid of those off-target toxicities, there are nuclease-free strategies by base editing and other advanced peptide nucleic acids. Now, madam, 30 seconds. So there are certain splice site mutations. If you just cover it, the normal splice comes. So it is akin to, when there's a pothole, you repair it, but if it's done like it's done in our country during monsoon, next year the pothole will come. So then you use your modified U7 SNRP. I've talked of the nuclease-based therapies. Your targets are hemoglobin F induction or strategies based on gamma globin reactivation. These are non-nucleases. And the task ahead for India is none of these technologies. It's basically prevention in terms of education, political will, non-invasive prenatal diagnosis, POC screening. And I think if you have to talk of care, empathy, comprehensive care, clinical trials with the molecules which we have, and research and innovation. Thank you very much.
Thank you, Dr. Pranta. It was a very good lecture. I feel that in the nutritional aspect, you said about vitamin D and folic acid, but we should also give B12 because many of them have subclinical, diagnosed or undiagnosed B12 deficiency in the background. And when it comes to sickle cell disease, hydration is important, but we have not provided safe drinking water to our people. That is another aspect.
I fully agree with you, and nowadays you can motivate people. There will be alarms. Have you taken enough fluids and all? But the first thing is potable drinking water. Anyway,
So sickle cell disease prevention means prevention of crisis, which primarily depends on preventing dehydration. And when it comes to long-term prevention, I feel that it is due to the malaria endemicity in India. So fresh mutations can be stopped only if you stop malaria. That brings us to waste management. So things like that should be talked about in doctors' meetings. Thank you.
I know.
Thank you.
Thank you. It's open for a
Any questions? Any questions?
Yes, Dr. Gupta.
Yes.
Because what I have seen in the country across, how many of you, as a hematologist, are advocating the use of leuko-reduced blood? Because what I have seen in the country, presently, let me tell you, 5 lakh bags of leuko-reduced integrated filters are used in the country for all types of the patients out of the 12.5 million units which are collected across the country. I have not seen most of the hematologists are asking leuko-reduced blood. And if they are asking, they are using what we call bedside filters, which is actually not ideal. Because when you collect the blood, the leukocytes disintegrate.
So the cytokines are already there.
So you are not doing any justice. You are actually helping the companies to get sale of this thing. So I think the question needs to get in your minds to see that what you need to practice.
Yes, and I think even the complete RBC phenotype, the group phenotype, I think...
That is not done at all. And this is, I had published a study on this, And this is the need of the hour, and there is what the hematologist can help the patients. And this is the need of the hour, what you can do at a very little cost.
Yes.
Thank you, Pranta, for a very nice presentation. I had a very simple question.
Yeah, tell me.
Hydroxyurea, 5-azacitidine have been introduced in management of sickle cell disease to increase the fetal hemoglobin for decades now. What are there data to show any increased incidence of malignancies in these patients who are receiving these drugs, cycle-specific drugs actually?
We have not used hydroxyurea for a very long time, but if we look at the sickle cell cohorts, it has been proven that it does not lead to secondary. So obviously it's a safe drug, but the way to use hydroxyurea, that is where India needs to do, you know. So how to use it, where to use it. Yeah, so 20 years data is there, there is no increased chance of malignancy with hydroxyurea. Yeah.
It is a safe drug in...
It is a safe drug.
Thank you.
Thank you, sir.
Thank you. We will go to the next topic. Updates in management of PNH. Dr. Niti Jain from Pgi-Hem Hospital, Mumbai. Dr. Niti has done DM clinical hematology from PGI, and areas of academic interest are acute leukemia, lymphoma, and classical hematology. PNH, as you know, is a very vexing clinical problem. The diagnosis missed very often. And when it is picked up, it is difficult to manage, and the prognosis is sometimes difficult to predict. Okay, over to Dr. Nitiji.
Thank you, Chairpersons. And at the outset, I would like to thank the organizers and my alma mater institute for having me here and providing this opportunity. And I would like to begin this talk with a disclaimer that I have minimal experience of using the newer, latest advances which is there in PNH, mainly because of the availability and the cost issues. So we all know that PNH, it is a rare disease that originates from somatic mutation in the X-linked Pgi, that is phosphatidylinositol-glycan anchor biosynthesis class A gene within the hematopoietic stem cell. Now for decades, PNH has attracted a lot of attention, which is inappropriate, for disease which is so rare. The prevalence is just 0.5 to 1 per million in the general population. And since, despite of that, it has attracted a lot of attention, and there is a lot of research which is going on in PNH in terms of the therapeutic advances. And this is probably because it is considered as the prototype of a non-malignant clonal disorder characterized by complement-mediated hemolytic anemia. And it was first reported in the literature in the later half of the 19th century. And why is it called PNH? Because it was a mistaken belief that the hemolysis and the hemoglobin urea occurs in a paroxysmally or episodically and more in the nocturnal hours, but that is, we know now that it is not the case. So in order to understand the advances, first I would like you all to go through the pathophysiology, because it is very important to know the drug mechanism. So it is a complement-driven hemolytic anemia, and it begins with the clonal expansion of the stem cells harboring a somatic Pgi mutation. Now, why this clonal expansion occurs of a mutant hematopoietic stem cell was a matter of debate, and several hypotheses has been proposed. One hypothesis is a model of two-step hypothesis, wherein the first step is clonal selection. That means in case of, in conditions of immunological attack to the bone marrow, there is a selective survival advantage of this Pgi mutant hematopoietic stem cells. And in the second event, because of second genetic or epigenetic event, there is further clonal expansion of this mutant hematopoietic stem cells. Now this Pgi mutant gene product is important for synthesis of the GPI-anchored proteins, GPI-anchored glycolipid moiety, which is important for attachment of various proteins on the cell surface. So similarly, the hematopoietic stem cells which lack this GPI-anchored protein in PNH, what happens is we need to understand the complement cascade first. Normally, as you see, all the three complement cascade, the classic lectin and the alternate pathway, pathway leads to the activation of C3 convertase, which cleaves C3 into C3b and C3a, and C3b then leads to activation of C5 convertase, which ultimately leads to the formation of terminal, which activates the terminal complement component and lead to the formation of the membrane attack complex. Now this membrane attack complex, what happens in a normal cell, because of the presence of CD55 and 59, CD55 is the decay accelerating factor and CD59 is the MIRL. Both of these protects the cell from complement mediated lysis by inhibiting the C3b and the MAC respectively. But in a PNH cell, there is lack of this GPI anchored proteins, and that is why the PNH cells are susceptible to complement mediated lysis. Now, if I go on the clinical part, it is subcategorized into 3 subgroups. That is the classic PNH, where the clone size of PNH cell is more than 50%, and there is active intravascular hemolysis plus minus thrombosis. And the second group is when PNH is associated with a bone marrow failure or syndrome or MDS, where the clone size is around 20 to 30%. This is mainly dominated by cytopenias, but there can be intravascular hemolysis. And the third subgroup is where PNH is a subclinical PNH, where the clone size is less than 10%, and practically there may be no hemolysis. So we all are aware of the unique clinical triad which the PNH patients can present with. That is the intravascular hemolysis, thrombosis, and bone marrow failure, or any combination of these 3. And this is the various symptomatology which can be observed in the PNH patients. I would directly jump into the management part, otherwise I won't be able to finish it. So regarding the management of PNH, historically, and rather I would say in our country today also, we resort to measures such as blood transfusions, erythropoietin stimulating agent, corticosteroids, anabolic steroid, iron therapy, because these patients are also iron deficient, thromboprophylaxis, and in eligible candidates, allogeneic bone marrow transplantation, because that is the only curative modality. Now, if I talk about the Western world where the newer agents are available, before 2007, the PNH mortality at 5 years with best supportive care was about 35%, with a median survival of 15 to 20 years. But now, since 2007, since the approval of eculizumab, which is a complement C5 inhibitor, the survival rates of PNH patients have dramatically improved, and they now match that of the normal age-matched control if they are appropriately treated. So going into the development of these complement inhibitors in PNH, so now we have 3 complement inhibitors which are approved for the treatment of PNH, including eculizumab, ravulizumab, which is the second C5 complement inhibitor. Third, the latest approval is for pegcetacoplan, which is a C3 inhibitor, and there are multiple agents or a new plethora of drugs interfering with the proximal as well as the terminal complement cascade, and they are under recent development. The 2 oral drugs, that is factor B inhibitor and factor D inhibitor, which affects the proximal complement pathway, are in the advanced stage of clinical development. So looking into the C5 complement inhibitors, as I have already showed you that how the complement mediated hemolysis occurs. So C5 inhibitor, that is eculizumab and ravulizumab, it binds to the C5 and prevents the cleavage into C5b, and thus prevents the formation of the membrane attack complex, and hence the intravascular hemolysis can be prevented. But what happens is the proximal complement cascade is still active. So there is a constant activation of C3, and there is generation of the fragments such as C3d, which goes and coats the cells which have been spared by the lysis of by the MAC in the presence of a C5 complement inhibitor, and these coated fragment loaded cells get opsonized by the reticular endothelial system, and what we get is the extravascular hemolysis. So all the patients who are receiving C5 complement inhibitors are prone to develop extravascular hemolysis. So in general, this class is well tolerated, effectively controls the PNH associated intravascular hemolysis. There is prevention of thrombosis as well, but the limitations are that the treatment is to be continued indefinitely. They do not ameliorate the PNH associated bone marrow failure, does not stop the extravascular hemolysis because of which the patient can still remain anemic, and the most important part for us is that they are exorbitantly expensive. So the eculizumab, which has revolutionized the treatment of PNH, the this is a humanized monoclonal antibody given as intravenous dosage, loading dose of 600 mg weekly into 4 weeks, followed by a maintenance dose of 900 mg every 2 weeks thereafter. As it does not alter the underlying defect of the disease, the treatment needs to be continued lifelong. And just have a look at the cost. So the cost is approximately 3.3 CR per year. And if a patient has to afford this, has to take this lifelong. So it's out of reach for, I think, all of the patients, at least in our country, where they have to pay from the pocket. Now, even after receiving this drug, 2/3 of the patients are transfusion independent, but 25% of them may still require transfusion, and that is mainly because of certain limitations, which I will be talking in a while. One more problem with this class of drug is that there is almost 1,000 to 2,000-fold increased risk of meningococcal disease, and hence they need to be vaccinated against meningococcal. Looking into the data about eculizumab, it was first reported in 2004 in a pilot study where it was shown that eculizumab is safe, well tolerated, it leads to reduction in the extent of hemolysis, hemoglobin urea, reduced need for blood transfusion, and improves the quality of life. This was the pivotal phase 3 trial which led to the approval of eculizumab in the PNH patients, the TRIUMPH study, and you can see that it was very effective in achieving transfusion independence. Similarly, the Shepherd study also showed the same result, reducing transfusion requirement, improved less hemolysis, and improved hemoglobin. And this was a real-world data which showed a long-term efficacy of eculizumab, and it showed that prospectively it confirmed a significant survival benefit in PNH patients on eculizumab, but it also pointed out towards limitations such as breakthrough hemolysis, extravascular hemolysis, lack of bone marrow failure control, and further clonal evolution, and hence it led to the development of newer complement inhibitors and stressed the need of bone marrow transplant as the curative option. So as I've mentioned, eculizumab can be...
Please wind up passing.
Yeah, sure. Sorry? Fast, yeah. So next drug was ravulizumab, which came with a longer terminal half-life, and so eculizumab has to be used every 2 weekly. This can be used every 8 weekly, and it is similar in efficacy to eculizumab. And this is the data regarding ravulizumab, which again it showed that the safety and tolerability of ravulizumab and eculizumab was similar, and it has better PK/PDs, and so it is a better drug. And then because of the extravascular hemolysis occurring in the C5 inhibitors, it led to the researchers to look into the proximal complement inhibition, and hence came the C3 inhibitor pegcetacoplan, and this is a Pegasus trial which led to the approval of pegcetacoplan. This trial showed that C3 inhibition was superior to C5 inhibitor, improving the hemoglobin, clinical, and the hematological outcomes. So C3 inhibition, the advantages being it is superior efficacy compared to C5 eculizumab, in improving hemoglobin and improvement in the clinical and hematological outcome. Other important part is that it can be given subcutaneously. So there is a scope for self-administration, well tolerated with few side effects. But the problems, again, cost, I would say, is the most important problem for us. And there is a twice weekly application. So again, it is very inconvenient for the patient. It leads to increased risk of infections, meningitis, streptococcus pneumoniae, and H. influenza infections. So patient has to be vaccinated. And there is limited clinical and real-world data experience as of now. Changing gears, coming to the role of allogenic transplant in PNH. So this is currently the only curative therapy in PNH. But again, because it is associated with high transplant-related mortality, which should be very, only the eligible patients should be chosen for. And this, it is particularly indicated in patients who have an accompanying bone marrow failure, who have hemolysis or thrombosis, which is refractory to eculizumab, and in countries where eculizumab is not available, or there is another concurrent marrow disorder along with PNH. Data regarding the utility of transplant in PNH is very minimal, and we have this retrospective analysis from the Polish group, which showed the very good 3-year overall survival probability of 88.9% in patients with classic PNH.
So just a slide about the thrombosis in PNH. So this is a leading cause of morbidity and mortality in PNH, and almost 29 to 44% of the patients had at least one thrombotic episode. But because of the use of this eculizumab and other complement inhibitor, the thrombotic event, the risk has reduced from 7.37 to 1.07 per 100 patient year once the patient has commenced on this particular drug. So just to summarize the use of complement inhibitors in classic PNH, so it is now considered a standard of care for patients who have classic PNH with the clone size of more than 50% and adequate bone marrow reserve. In case of breakthrough hemolysis, we can think about switching eculizumab to a better drug, that is revalizumab, and these are the various drugs which are approved. 3 of them I have already mentioned, and few of them who are in the clinical trial in the advanced phases and can be approved soon. Particularly attractive are the 2 oral drugs, the iptacopan and the danicopan, which are factor B and factor D inhibitors respectively, and they can again change the whole game of treatment of PNH. So just to summarize, this is my last slide. How do we manage PNH in today's era is that we have to see whether the patient has a bone marrow failure or not. If there is a bone marrow failure and the patient is a candidate for an allogeneic HSCT, then we should proceed ahead with transplant. If the patient is not a candidate for hematopoietic stem cell transplant, then they should be treated with the immunosuppressive therapy. And we need to see whether PNH-associated significant findings, that is intravascular hemolysis or thrombosis, is present or not. If it is present, then we can add the complement inhibitor and monitor the response to the therapy. If that is not present, then we need to monitor the PNH clone. If the patient is not having a bone marrow failure, then we need to see whether PNH-associated clinical findings are significant. Then we need to go ahead with complement inhibitors in countries where it is available, not for us, at present at least. And if they do not have significant clinical findings, then they can be monitored closely. And I would end my talk with the hope that soon we have all these 3 new agents which are available to the rest of the world for our PNH patients so that we can treat them better. Thank you.
Thank you, Dr. Nidhi Jain, for updating us on PNH management. Any questions from the audience?
You did mention about monitoring the response to therapy, and I assume you are talking about flow cytometric assessment of the PNH cells.
Yeah.
I just wanted to comment that as one would expect, and just for the audience, when you are giving these drugs, eculizumab, you are preventing the PNH cells from lysing. So paradoxically, although the patient improves, the clone or the cells that you pick up in the peripheral circulation would be increasing as well. So that's actually a success story in this case.
Right.
So I just thought I'll bring this up.
So regarding monitoring part, actually we need to monitor whether the patient is responding in terms of decreasing the intravascular hemolysis. Like LDH is a very good marker, increase in hemoglobin. So those are treatment responses. As I mentioned, these drugs do not change the underlying disease at all. So we do not expect the PNH clone size to go down with these drugs. It will increase. But sometimes we've seen that over a period of time, if suppose the patient is not symptomatic at the baseline, we did not start these drugs, and we repeat after 6 months, we repeat their clone size. Sometimes we may find that the clone size go down. Even after transplantation, as that is the only curative modality, the studies have shown that after transplant, the PNH clone size can be decreased to less than 1%. Yeah, LDH is the most important marker. I would just share my experience of using eculizumab in 2 patients for a very short period of time, wherein the patient was transfusion dependent, having 4 or 5 hemoglobin LDH above 3,000. The moment we started eculizumab with the first dose itself, the LDH went down to 400, 500. And his hemoglobin also improved to 11 dramatically with just single dose of eculizumab. But then he continued to have that small amount of extravascular hemolysis, which was not significant. So we just continued the patient on eculizumab.
Hello. Yeah. Is there indication for this way?
Yeah, sorry.
Any indication for using anticoagulant as a prophylaxis for thrombosis. What are those indications?
Yeah, so I had that in the thrombosis slide, but because of paucity of time, so primary prophylaxis and secondary prophylaxis. So if suppose a PNH patient already had a thrombotic event, then actually and the clone size of PNH is more than 50%, the recommendation is that, the expert recommendation, we do not have very strong data, that the patient should be on lifelong anticoagulation if there is no access to the complement inhibitor therapy. In terms of, if I talk about the primary prophylaxis, again, for us, if the clone size is very high, LDH is very high, the patient does not have any contraindication for antithrombotic agents, then we should consider the patient for primary prophylaxis if we do not have access to complement inhibitors.
Thank you. We will wind up this session and go to the next part, that is panel discussion. Madam. Next is a panel discussion on management of immune hemolytic anemia. I request Madam to take over.
I think we have a panel discussion which will be very interesting, and I invite the panelists. They are Dr. Pooja Murgai, Dr. Rajiv Sandal, and Dr. Ashok. And also Dr. Bhattacharya Urmila. So this is on the topic, that is the management of immune hemolytic anemia. And the moderator is Dr. Ankur Jain. So I invite this to start on time.
Thank you, ma'am. May I like to invite my panelists on the stage for the panel discussion? To invite them again? Ma'am is leaving?
We will get more chairs.
Okay. So after the exciting sessions on non-immune hemolytic anemia, I would like to start the panel discussion on the management of immune hemolytic anemias. Since my talk is starting at 12:22, I expect 10 minutes more for my discussion. So a few slides on introduction. Autoimmune hemolytic anemia is a rare type of hemolytic anemia, incidence being 5 to 10 per million population. It is characterized by destruction of red cells by the autoantibodies, generally IgM or IgG, or rarely IgA subtypes. Coating of RBCs cause destruction of red cells either in the reticuloendothelial system, which is called extravascular hemolysis, or the red cells undergo complement-mediated destruction, which is called intravascular hemolysis. What is most important is that in both types of both types of AIHA, both the mechanisms operate simultaneously. And the site of hemolysis depends upon the type of antibody. So definition of AIHA is presence of hemolysis, positive Coombs test, and exclusion of the alternative causes of hemolysis. Coming on to pathophysiology of autoimmune hemolytic anemia, because of immune dysregulation, there is production of the autoantibodies. If the antibodies are of IgG subtype, they cause coating of red cells which undergo destruction in the spleen, which is a mechanism for warm AIHA. If the antibodies are of IgM type, the coated red cells undergo destruction in the liver, which is a mechanism for cold AIHA. And in both the subtypes of AIHA, there is concomitant intravascular hemolysis as well. So that's a very important point that in contrast to classical teaching, the intravascular hemolysis operates in both subtypes of AIHA. Just one slide on the approach to diagnosis of AIHA. Once you suspect the patient as having autoimmune hemolytic anemia, you order a Coombs test, polyspecific Coombs test, which is positive, you order a monospecific Coombs. If the monospecific Coombs is positive for only IgG, the patient is labeled as warm AIHA. However, if the monospecific Coombs reveals C3d positivity, we do a titer of antibody. If titer is more than 64 and if it's only C3, the patient is labeled as cold AIHA. If the titer is above 64 but the patient has both C3 and IgG, it is called mixed AIHA. And if the titer is less than 64, that means the cold antibody is not significant, then the patient could be having warm AIHA in the absence of paroxysmal cold hemoglobinuria. So I will have two cases, real world cases, and discuss both the scenarios via panel discussion. So case 1, a 40-year-old lady, known case of type 2 diabetes. She came to clinic with fatigue for 3 months. On examination, she was pale and the liver and spleen were palpable. There was no lymphadenopathy on the clinical examination. On investigation, she had anemia, HB of 4.5 grams, and TLC and platelets were normal. Retic count was 2%. MCV was high, and PS showed a lot of microspherocytes. She had indirect hyperbil, high LDH, and polyspecific Coombs was positive for for IgG, and C3d was negative. So the patient was labeled as warm AIHA. So first question to Dr. Pooja is that this patient had retic count of 2%. So first question is, can you have low retic count in a patient of AIHA? Audible.
Usually in hemolytic anemia, as we see, there is an increase in reticulocyte count. But in AIHA, we can have the cases with low reticulocyte count. In up to some of the studies says in up to 20% of the cases they have a low reticulocyte count. So there can be many causes of the low reticulocyte count in AIHA. For example, if the patient is having concomitant sepsis, so marrow is already in shock, so it cannot compensate for the degree of hemolysis and anemia. Secondly, if there is autoantibodies against the erythroblast, so marrow will be like a hypoplastic type marrow. And thirdly, if elderly patients if there is a stem cell reserve is low, so if they have a lymphoproliferative disorder or metastatic disease in the marrow. Lastly, if there is infections like parvovirus, V19, etc. with the AIHA.
Absolutely. So what is most important is that about 1/3 of patients of AIHA have reticulocytopenia. These patients have very poor outcomes because of the extremely high transfusion requirement. So a bone marrow responsiveness index has been proposed to take into account this problem, which is calculated by multiplying patients' absolute retic count with the ratio of patients' HB to normal HB. And if this index is less than 121, it suggests hemolysis with concomitant reticulocytopenia. And the possible causes could be concomitant bone marrow involvement either by the heme malignancy or bone marrow failure syndromes, deficiency of vitamins, infections, and most importantly, autoimmune process against the bone marrow precursors. Next question coming to Dr. Pooja again. What are the possible causes of Coombs negative AIHA? I mean, we commonly see patients of AIHA whose Coombs test is negative. So what can be the possible causes for that?
So Coombs test can be negative if there is a low titer of the antibody, or if there is a low affinity antibody, or if there is a IgM or IgG, in spite of that, there is a IgA or other type of the autoantibody present.
So as Dr. Pooja has highlighted, there are various possible causes for Coombs test being negative, most important being that IgG is there in low concentrations, which we are not able to detect by the classical Coombs test. For that, we can increase the sensitivity by doing a flow cytometry, or we can do a column of the gel test. Another causes could be the low affinity IgG antibodies, which are washed off when we do the Coombs test. So for that, we could use the low ionic saline solution. or because the Coombs test generally measures IgG and C3 and does not take into account rarer IgA antibodies that could be accounting for the Coombs negative AIHA, and we could use the anti-IgA sera to look for those rare IgA antibodies. And most and least important cause is the hemolysis is because of the natural killer cells, for which we can use a chromium labeled release assay to detect the natural killer cell mediated hemolysis. So this is an algorithm to show how do we diagnose Coombs negative AIHA in a patient in whom we suspect AIHA and the Coombs test is coming negative. We should also rule out other causes, which includes PNH and Wilson's disease and congenital hemolytic anemias, and we also should do the more sensitive variants of DAT, which we have discussed in the previous slide, and then only we should label a patient as having truly DAT negative AIHA, and these patients account for less than 10% of all the AIHA cases. So coming on to our index case, a warm AIHA patient, 40-year-old lady. What other investigation should be done in this patient? Again, Dr. Pooja can answer.
So in this patient, we can see the haptoglobulin levels, LDH level, and bilirubin, unconjugated bilirubin will be raised. And others, we can rule out the other secondary causes of the AIHA, like lymphoproliferative disorders. And we can do the acute for the autoimmune disorders like double standard DNA and anti-nuclear antibodies we can test, and we can do bone marrow if patient, she is not an elderly patient, so we can skip up the bone marrow. We can, if she is pregnant, then we can rule out the HELLP syndrome by doing the further investigations.
Okay, so first of all, we should differentiate between primary and secondary warm AIHA. That is our whole idea of doing these battery of investigations. So this is a list of list of secondary causes of warm AIHA, beginning from lymphoproliferative disorders to solid tumors to autoimmune and inflammatory disorders and primary immunodeficiency disorders, certain infections and post-transplantation. So this is on left hand side, this is a Western data, and on right hand side, it's an Indian data on the secondary causes of warm AIHA. We should remember that around 50% of patients of warm AIHA have a secondary cause. Amongst the secondary cause, half of patients have malignancies, which includes lymphoproliferative disorders. Half of patients have immune disorders, which includes autoimmune like SLE, and a rarer subgroup of patients have warm AIHA because of the drugs or viral infections. On right side, there's an Indian data which corroborates with the Western data and show that around more than 50% of patients of warm AIHA have a secondary underlying cause, which we must find with the battery of tests. So this is a recommended battery of tests for chronic warm AIHA. In addition to classical HB, LDH, which all we have discussed, we must do serum protein electrophoresis to look for plasma cell dyscrasias, ANA, RA factor, flow cytometry on peripheral blood for clonal B cells, again CT scans for the malignancies, and bone marrow examination, which is a topic of further discussion. I will come on to erythropoietin levels and D-dimers in my subsequent slides. What is the role of these tests in patients of AIHA? So Dr. Rajiv, do you do bone marrow examination for all your patients of warm AIHA, or do you do it selectively?
No, we don't do bone marrow in every patient of warm IHA, only at the first relapse, failure of steroid, or if we are suspecting any bone marrow pathology, lymphoproliferative disorder. Then
Okay, so that's a contentious topic, but as I have discussed previously, around 50% of patients of warm AIHA have a secondary cause, and amongst those 50%, half are because of a lymphoproliferative disorder. And in one study, it was found that around 18% of patients of warm AIHA subsequently developed a lymphoma. So clearly, the presence of lymphoma in AIHA is underrepresented or underestimated, and it is advisable to at least do a CT scan of chest, abdomen, and pelvis, as well as flow cytometry of peripheral blood to look for a possible lymphoproliferative disorder. However, the indications for doing a bone marrow with flow cytometry obviously are that if your patient has features of malignancy, for example, lymphadenopathy or lymphocytosis on a peripheral blood smear, or the CT scan shows lymphadenopathy or hepatosplenomegaly. Also, all the patients of Coombs negative AIHA must have a bone marrow examination done, because we have to see the erythropoiesis, what is the status of erythropoiesis, and also to rule out the primary bone marrow disorders. So some physicians do bone marrow for all the patients, but we must do it judiciously because it's only for those patients in whom we really suspect CLPD, but we must consider that CLPD contributes to a substantial proportion of secondary AIHA. So coming on to index case, the patient was worked up, the SPEP was negative, free light chains were negative. We did bone marrow for this patient, but there was no clonal B cells, flow was negative for CLPD, and CT scan showed no adenopathy or hepatosplenomegaly, and ANA was negative. So patient was labeled, all the secondary causes were ruled out, and she was labeled as primary warm AIHA. So question to Dr. Urmi, what are the first line treatment options for warm AIHA? Primary warm AIHA.
So it is, so for this patient, we will go for corticosteroid, prednisolone, oral at the rate of 1 mg per kg, or we can also go for a pulse methylprednisolone, 500 to 1000 milligram. So the starting dose for prednisolone is 1 mg per kg, and we'll give it with a tapering dose over a period of 4 to 6 months.
Okay, so I will begin this topic of discussion with just a slide showing the sites of action of various drugs in AIHA. So we can have various sites of action. So corticosteroids and rituximab reduce the formation of antibody. Danazol and erythropoietin increase the marrow production of red cells, and splenectomy reduces the erythrocyte phagocytosis. So as she has correctly mentioned, corticosteroids are the frontline management for primary warm AIHA. And corticosteroids have got a response rate of about 90%, but majority of these responses are not sustained, and only about 1/3 of patients are cured at 1 year. About 2/3 of patients relapse once we taper the corticosteroids. Another thing is that occasionally we can also use IVIG as frontline therapy for warm AIHA, although the responses are 30%, but it's a short-acting drug, so responses are very short-lasting, and almost all the patients relapse. So it's only used for emergency situations in patients of AIHA. Why I put this question was that can we use rituximab as a frontline therapy in combination with prednisolone for patients of AIHA? And the answer to this question comes from 2 randomized trials. The first was published in Pgi-Hem in 2013. The second was published in American Journal of Hematology in 2007. In both of these studies, prednisolone was combined with rituximab frontline and was compared with prednisolone alone for patients of AIHA. And both the studies had similar results. At 1 year, 2 year, and 3 year time points, the overall response rates and CR rates were better with the combination as compared to the prednisolone alone. And that is why we could consider adding rituximab to frontline prednisolone in selective patients, not for all the patients, for patients who have got severe hemolysis, HB less than 8, or transfusion-dependent IgA type or Evans syndrome. For these patients, we could also add rituximab to the backbone of prednisolone. For all other patients, prednisolone is a standard of care. Next question is that to Rajiv, how do you define treatment response in patients with AIHA?
Sir, we define treatment response as complete response when patient HB is normalized, there is no biochemical feature of hemolysis, and patient is transfusion dependent. Or we define response, increase in HB more than 2 gram per liter, and transfusion free for 1 week, but there is biochemical feature of hemolysis.
Okay, so I came across with this very nice systematic review, and this whole review focused only on one topic, defining autoimmune hemolytic anemia. This was a very interesting review article because it was a systematic review of 84 articles regarding definition of defining AIHA, response assessment, duration of response, refractory, and relapse. This article really signifies the heterogeneous nature of all these definitions. When we go into clinical practice, every physician has its own way of defining response to the what is actually PR, what is CR, and what is response to the AIHA. I'm very sorry for the font size because it was a huge table in the article and I had to take multiple snapshots and merge them into a single slide. But what is most important is that CR was defined variably. Some physicians defined CR as HB more than 12, some defined normalization of HB, some defined HB as more than 10. And similarly, the partial response was defined variably. Some physicians or some clinical trials defined HB as above 10. And all these studies were highly heterogeneous, so this made the response assessment and cross-trial comparisons very difficult. Therefore, a uniform definition was proposed for the purpose of clinical trials by the Society of the Autoimmune Hemolytic Anemia, and response was defined as increase of hemoglobin by more than 2 grams per deciliter, or normalization of hemoglobin without a biochemical resolution of hemolysis. Whereas in CR, there is also the biochemical resolution of hemolysis in addition to the normalization of hemoglobin. And this we see very commonly. When we start corticosteroids, the HB increase, but the LDH is still high, and sometimes the LDH is normal. So we should also see whether there is biochemical hemolysis ongoing, or the biochemical hemolysis has also stopped to properly label patient as CR or just a response. Next question to Urmi, that this patient supposedly achieved a response or a complete response, then how would you taper corticosteroids in this case?
So once a response has been achieved, we gradually decrease the steroids at the rate of firstly at the rate of 10 mg every week or 2 weekly. And gradually we assess the response frequently at the every 2 weekly or 3 weekly. And if the sustained response is maintained, and once the steroid dose has come down to 20 mg per day, then gradually we decline the dose at 5 mg per week and to 5 mg once daily dose, and gradually alternate daily dose, and then stop over a period of 4 to 6 months.
Absolutely. So what is most important take-home message is that the corticosteroid tapering in AIHA must be really slow. This is in contrast to the ITP, where the patient must be off steroids in 6 weeks. So in a steroid responsive patient, we can start tapering after 2 to 3 weeks, but we must not taper steroids in less than 6 months. Otherwise, the relapse rates will be pretty high. In addition to hemoglobin values, as I have mentioned, we should also monitor hemolytic parameters, which are the LDH and bilirubin and the reticulocyte count. All the patients who required more than 20 milligram prednisolone dose for over 1 month must be on Septran prophylaxis. Once we start corticosteroid tapering, only about 1/3 of patients maintain response at 1 year, and 2/3 of patients relapse and they require additional therapy. So take home message, we should taper corticosteroids over 4 to 6 months and not less than that. So coming on to Rajiv, what are the indications and for second line therapy, and for second line therapy, which agent would you prefer?
Sir, failure of steroid therapy. So we start second line, patient unable to maintain the HP less than more than 10. Second line treatment for warm AIHA, we usually use weekly doses of rituximab. So we use 375 milligram per meter square for weekly for 4 weeks in our center.
Okay, so we should be very clear when should we use second line therapy in AIHA. First of all, if the patient is steroid refractory, as Rajiv has mentioned, and the definition is no response to steroids after at least 4 weeks of trial. So 4 weeks of corticosteroid full dose, if there is no response, then patient is labeled as steroid refractory. Steroid dependent AIHA, sometimes patient respond to steroid, but once we start tapering them, the patient has a relapse. That is steroid dependent. And third is that once we stop corticosteroids, and if there is a relapse, then the patient should be on second line therapy. For the drugs, the preferred is rituximab. Previously, splenectomy was also there in the second line therapy, but now the role of splenectomy has shifted quite back, and we will discuss it subsequently. So preferred agent is rituximab in the second line therapy. And dosing, as Rajiv mentioned, classical dosing is 4 weekly infusions of 375 milligrams per meter square, but there are 2 more regimens. One is 1 gram IV at 2 weekly apart, and most importantly, 4 weekly infusions of fixed dose of rituximab, which is 100 milligrams per week. And why this is important, I will come to in the subsequent slide. So this was a review, not a review, it was an original study which was published in Blood, which mentioned about 10-year experience of using low-dose rituximab as a second-line therapy for AIHA. So in this study, the authors used 100 milligram fixed dose weekly into 4, and then they found that the efficacy of low-dose rituximab was as equal as the standard infusions of 375 milligrams per meter square times 4, in both in terms of the CR CR rates as well as in terms of the relapse-free survival. So the relapse rates and response rates were essentially similar in both the groups of patients. So this is a very important study which highlights that we can reduce cost of our therapy by just using a fixed dose of rituximab rather than using a higher dose of rituximab, because the response rates are essentially similar. So coming to Dr. Urmi, what are the options for third-line therapy?
So, in India, third-line therapy, we generally, there are multiple drugs that we can try. So, azathioprine is quite promisable option, 1 to 2 mg per kg, maximum 150 mg daily dose. So, that is one option. Second, other modalities that are there are cyclophosphamide, cyclosporine, then danazole, sirolimus. These are mycophenolate mofetil. These are the other options that we can go for.
Exactly, as you have correctly mentioned, this is a table just showing the possible third-line options for warm AIHA, ranging from mycophenolate to cyclosporine to endoxin, azathioprine, danazole. And we can see that splenectomy comes last in the management of warm AIHA, as in contrast to the previous publications where splenectomy was the second-line therapy for the warm AIHA, and the response rates are variable in the studies, and the response time to response is also highly variable. But importantly, if someone is doing splenectomy for warm AIHA, the cure rates are high. This is almost like ITP when, although the morbidity of the procedure is also high in terms of septicemia and thromboembolism, the response rates are high and the response rates are maintained over a long period of time. But not many of the patients choose splenectomy in this disorder because you get a big scar and you are into a lot of trouble because of the complications. So that's the thing. So this is just a flow chart showing the first line, second line and third line management as we have discussed previously. So first line is corticosteroids with or without rituximab. Second line is rituximab. Third line is immunosuppressive drugs, a table which I showed previously. And then at the end we can have splenectomy. So coming on to first case, the case which I mentioned, this was a real world case. So this patient was diagnosed with warm AIHA primary. We gave her prednisolone, she achieved CR. After 4 weeks, we were tapering her corticosteroids, but because she was diabetic, her steroid she had uncontrolled blood sugars, and once we were tapering steroids, she was relapsing. So basically she was a steroid dependent case. So we gave her a second line therapy with the rituximab, 4 infusions as we mentioned. And with rituximab, she achieved only partial response. But even with partial response, she was transfusion independent and she was continuing for another 6 months. After 6 months, she relapsed. So we gave third line, which is azathioprine, but because of azathioprine, she had myelosuppression. So we exhausted first line, second line, third line. We gave her an option of splenectomy, but she said she does not want splenectomy. So what options now do we have for this patient who has exhausted first 3 lines of therapy and she denies splenectomy? Dr. Urmi, any role for bortezomib and Darzalex for warm AIHA?
Yes.
Can you use bortezomib?
Yeah, so bortezomib, a trial of bortezomib can be given. Daratumumab has also been reported in different case reports, but large studies are still awaited with these agents.
Okay. So I already showed the answers, that is why I switched back to the previous slide. As we can see that the antibodies in AIHA are produced by both the long-acting B cells, which eventually transform into plasma cells. So it's a novel strategy of targeting these drugs, targeting plasma cells by the anti-myeloma drugs, which are the bortezomib and the Darzalex. So if we combine bortezomib or Darzalex with the high-dose dexamethasone, we are reducing the antibody formation and we could possibly control AIHA. And this is a review article published, it is in Blood, which showed the role of bortezomib for the management of relapse refractory AIHA. So it is a review article which combined all the case series and case reports, and only 29 patients were evaluable. But what is most important is that the median number of prior lines of therapies were 5. That means we are talking about a truly refractory cohort of patients. And we can see that the overall response rates using either bortezomib or combination of bortezomib was 78%. So if we use a single agent bortezomib or a combination of bortezomib, we are expecting a pretty high response rates, and the onset of response is only 3 weeks. So a very quick, rapidly acting drug and quite high response rates. So it is a potential drug which you could use for the patients of VOM-AIHA who are not responding to prior 3 lines of therapies. Couple of years back, we reviewed the role of daratumumab for the management of hematological malignancies and other uses. This is our review article published in Clinical Lymphoma, Leukemia and Myeloma, and we showed that, and we reviewed that the daratumumab could be used for both benign as well as malignant disorders. This is because the CD38 is expressed not only on the malignant plasma cells but also on the benign plasma cells and the B cells. And this forms the rationale of using Darzalex for a lot of benign conditions including AIHA, PRCA, and subsequently after this publication the role of Darzalex also came in ITP and immune TTP. So a lot of immune conditions could be managed with Darzalex, and this is a recent publication published just 2 months before in American Journal of Hematology, where 8 patients were mentioned. Amongst the 8 patients, 2 patients, patient number 4 and 5, were given daratumumab and as a salvage kind of a therapy, and both the patients responded to daratumumab. So as you correctly mentioned, there are no large-scale studies, there are only case series or case reports, but they are quite encouraging, and we may have later a clinical trial on these drugs. So coming on to Rajiv, any role of erythropoietin in AIHA?
So erythropoietin can be used as a supportive therapy in patient with low endogenous level of EPO level. So we can use erythropoietin, high dose of erythropoietin.
So in the workup table, I mentioned that erythropoietin levels may be done for AIHA patients. I'll come to this point now. As I also mentioned that 1/3 of patients of AIHA have a reduced reticulocyte count. And it was found in various studies that the patients of VOM-AIHA have relatively low erythropoietin levels as compared to other forms of anemia. Both of these forms rationale for possible use of erythropoietin in patients with VOM-AIHA, and we can see that at 1 year the response rates were 78%, and the median increase of hemoglobin was 2 grams per deciliter. So you can try erythropoietin in a cohort of patients of VOM-AIHA who have low reticulocyte count to begin with, and you can expect that these patients will have a 2-gram rise of the hemoglobin level to a maximum. So Dr. Urmi, what are the complications of VOM-AIHA? An apparently benign disease, so what are the complications of VOM-AIHA?
So complications I can think of this drug-related complications means if it is a relapsing disease or is like steroid dependence or long-term steroid-related complications is one of the things that I can think of in these patients in the form of osteoporosis and then cataract, low bone densities, Cushingoid features.
Any disease complication?
So, disease.
Okay, so as I mentioned previously that around 10% of patients of VOM-AIHA eventually develop a lymphoma or a lymphoproliferative disorder. So that's one possible complication. Second is increased risk of thromboembolism. So all the patients of AIHA, not only VOM, I'll come to cold in subsequent slides, both of them have a high risk of thromboembolism, and there is a rationale for using a thromboprophylaxis for some of these patients, which I think majority of us do not use in clinical practice, but then we must use prophylaxis for at least those patients who are hospitalized, non-ambulatory, or have a very brisk hemolysis. We must use thromboprophylaxis. And thirdly, because you have a hemolysis going on, so your HbA1c will underestimate the diabetic monitoring. So if a patient is diabetic and having VOM-AIHA, if you use HbA1c levels, you are likely to underestimate the sugar control. So these 3 things the third is not a complication, it's just a clinical point, but first 2 are definitely complications of the disease. So coming on to index case, which I mentioned previously, this patient was given 3 lines of therapies, denied splenectomy. We did not give her bortezomib because she was diabetic and had a neuropathy. We gave her Darzalex in a dose of 16 milligram per kilo per week times 4. She had a partial response to Darzalex, which was maintained for 6 months. and this case was published in Annals of Hematology a couple of years back, and this was a very one of the few cases at that time which looked into role of Darzalex into refractory warm autoimmune hemolytic anemia, and subsequently a lot of publications then came into. So case 2, 50-year-old male resident of Himachal Pradesh came in the month of December with fatigue and numbness. On examination, there was pallor, liver was palpable, only mild spleen was palpable, there were no lymph nodes. HB investigation showed low hemoglobin, MCV was very high, 130, and peripheral smear showed marked agglutination. Indirect hyperbilirubinemia, high LDH were there, and monospecific Coombs was positive only for C3D, and patient was labeled as cold AIHA. So first, Dr. Pooja, how do you handle blood samples in a patient who is suspected to be having cold AIHA?
So as we know that in cold AIHA, the agglutination occur at a lower temperature. So we have to maintain the temperature 37 degree because these antibodies are reactive up to 30 degree of the centigrade. So we have to maintain the temperature at 37 degree in all the steps of the sample collection, from sample collection to sample processing and till the investigations are done. So for the peripheral blood smear, we have to pre-warm the syringes and we will keep the vacuum. So we will pre-warm the syringes and we will keep the vacuum also pre-warmed by keeping them into the beaker filled with warm water of temperature 37 degree. And if we are taking the sample for cold agglutinin titers, then we will keep the samples at 37 degree till we separate the plasma or the serum from the sample.
So absolutely. So this is a very important problem which is encountered in the clinical practice, that when we take a sample for cold AIHA, the blood gets clotted in the syringe and we are not able to send the blood sample for any investigation. So the patient must be, the extremities must be kept warm and the syringes must be pre-warmed, and immediately after taking the sample, we must transport the sample in a hot and a warm water bath till the sample reaches laboratory, where after separation of the serum, then the serum can be kept at the room temperature. Otherwise, there will be agglutination and clotting of the blood samples. So, Dr. Rajiv, how will you further investigate this case? Dr. Pooja, I think you can answer. How will you further investigate this patient of cold AIHA?
So, we will investigate the patient for the lymphoproliferative disorders, and in cold agglutinin disease, we can advise the bone marrow examination also to, if we are having indications from the peripheral blood smear examination or from the hemogram findings, then we can investigate for the infections, various infections, for example, mycoplasma pneumonia, infectious mononucleosis, CMV, Epstein-Barr virus, HIV, or hepatitis B or C infection.
Okay, so just like primary in warm AIHA.
Titers are important because titer and thermal amplitude.
Okay, so just like in warm AIHA, we need to have primary and secondary causes completely separated. So primary cold AIHA is known as cold agglutinin disease. There's a difference in terminology. So primary cold AIHA is called cold agglutinin disease, and secondary cold AIHA is called CAS, or cold agglutinin syndrome. So primary cold AIHA is defined as cold AIHA when no underlying secondary cause could be found out, which includes drugs or infections or autoimmune disease or any malignancy. So after exclusion of all the secondary causes, we have a primary cold AIHA or the CAD, and when you find any secondary cause, the patient is labeled as CAS. So what is most important is this CAD entity, because CAD entity is also a low-grade clonal disorder, because there are clonal B cells in the bone marrow, and on flow cytometry, the nature of these clonal B cells is different from any other lymphoma. It is different from marginal zone lymphoma or the lymphoplasmacytic lymphoma or the Waldenstrom's macroglobulinemia. So primary CAD is also a low-grade clonal lymphoproliferative disorder, and if you do MYD88 mutation, it will be characteristically absent. So we must be aware of the clonal nature of the primary CAD, and obviously secondary has a secondary causes. In pediatric population, there are mycoplasma pneumoniae, Epstein-Barr virus, which can cause secondary AIHA. In adult population, lymphoplasmacytic lymphoma or Waldenstrom's macroglobulinemia is the most important consideration. So based upon the previous list of causes, we can approach the patient like for cold AIHA, most important is doing a electrophoresis because lymphoplasmacytic lymphoma or Waldenstrom's is the most important cause in the adult population. So SPEP or IFE is most important, bone marrow is most important, and when we do a bone marrow, send a sample for both for the morphology and the flow cytometry, and preferably do a MYD88 mutation also, and do an autoimmune screening by ANA and dsDNA, and do a CT scan. If the pediatric population is there, then you can do mycoplasma serologies and Epstein-Barr virus DNA as well. But for adult population, these two are the most important considerations. So this patient was worked up and SPEP was found to be positive. M-band IF showed IgM kappa and light chains were elevated. Bone marrow showed paratrabecular lymphoid aggregates which were clonal on the immunohistochemistry, and the myeloma panel was negative, MYD8 mutation was negative. CT scan showed no lymphadenopathy, only mild hepatosplenomegaly, and autoimmune workup was negative. So since the bone marrow ruled out lymphoplasmacytic lymphoma or the Waldenstrom, so IgM kappa presence and lymphoid aggregates points towards primary CAD. So this patient was diagnosed with primary cold AIHA or CAD. So Dr. Rajiv, how will you treat, what is the first line treatment for primary cold AIHA or CAD?
So we use rituximab monotherapy for primary cold AIHA.
Okay.
Yes.
Okay. So this is a diagram showing how the red cells undergo hemolysis in cold AIHA. So B cell clones which are there in the bone marrow, they produce IgM kappa or the monoclonal protein, and the IgM antibodies which coat the red cells, and these red cells, once they bind with the IgM antibodies, once they bind the red cells at cold temperatures, they activate the complement. After the complement activation, C3b is produced, and C3b undergoes phagocytosis in the liver. It is very important to remember that in cold AIHA, the hemolysis is extravascular only in the liver. That is why even if you do a splenectomy, the patient will not respond, in contrast to the warm AIHA. And some of the red cells which escape the phagocytosis, they undergo the complement-mediated intravascular destruction as well. So to target or to treat the CAD, we can either reduce the B cell clones by using rituximab, or we can use other agents like complement inhibitors. So general measures for cold AIHA: always for blood transfusion, always use in-line warmers, otherwise they will be clotting of the blood lines. Avoid cold exposure, tell the patients to warm gloves and woolen clothes, because majority of these patients come in the winter season, so you need to completely cover the acral extremities of the patient. Sometimes if the hemolysis is very severe, you could use plasma exchange, because IgM antibody is predominantly intravascular, and we could remove these IgM antibodies by means of the plasma exchange. And we must remember that splenectomy is ineffective, as I have mentioned previously, and there is no role for corticosteroids or IVIG, in contrast to the warm AIHA. This is just a table showing the B cell directed therapies which we can use. So either we can use single agent rituximab, or we could use combination of rituximab with the bendamustine or the fludarabine. Since the combination of fludarabine with rituximab is very toxic and a lot of patients land up in neutropenia, neutropenic fever, we reserve it as a second line therapy. So for the first line therapy, we could use either single agent rituximab or the combination of bendamustine and rituximab. This is a flow chart which I have taken from How I Treat article in Blood, and we can see that if a patient is fit for therapy, we should prefer bendamustine rituximab. If a patient is frail and not able to tolerate bendamustine, even single agent rituximab is good enough for the first line management of cold AIHA. Dr. Urmi, second line for cold AIHA, after the patient has failed rituximab or
rituximab. So in that case, we can give a trial of bortezomib or ibrutinib. These are the different options. Very limited options are there so far. And newer therapies are now arising, so like sutimlimab in advanced, more developed countries.
Okay, so I am just highlighting a table of second line therapies. As I have mentioned previously, combination of fludarabine and rituximab can be used for second line. Since it is a clonal B cell disorder, so we can treat these patients like other CLPDs. So we can use BTK inhibitors like ibrutinib, or we can use bortezomib or PI3K inhibitors. The trials are undergoing. So we could use either of these regimens or therapies for cold AIHA. When I was a student, Dr. Verma said that you could use chlorambucil also for cold AIHA, chlorambucil rituximab, although it is not mentioned in the classical table. But because we are using chlorambucil prednisolone for CLL, so we can use chlorambucil rituximab or chlorambucil prednisolone for primary CAD as well. And this is again the American Journal of Hematology table of 8 patients. Amongst the 8 patients, patient 1 was cold AIHA. He or she was given daratumumab, and the patient, a male, so he was given Darzalex and patient responded. So there is obviously a role for plasma cell directed therapies here also, just like in the warm AIHA. And my last question to maybe Rajiv, any role of complement inhibitors in cold AIHA? Dr. Nidhi has discussed eloquently about the complement inhibitors in PNH.
So there are trial with C1 inhibitor is approved by FDA for cold AHA, and there is trial for C5 inhibitor Pgi-Hem-Onc. So we can use, but they are not any role in cold related symptom. They not relieve the cold related symptom.
That's absolutely correct. Since the hemolysis in cold AIHA is intravascular as well, and the intravascular hemolysis is basically because of the complement mediated process, there is definitely a role of complement inhibition. And as for example in PNH, we can use eculizumab, which is inhibitor of C5, C1s inhibitor, which is sutimlimab. It is the only drug which is approved for cold AIHA by the US FDA, and pegcetacoplan, which is undergoing the phase 3 clinical trial. What is most important is the last 3 points. Once we use complement inhibitors, we have to use them lifelong. We can reduce the intravascular hemolysis, but the proximal symptoms, ischemic symptoms do not reduce, because the binding of IgM with the red cell is not affected by these monoclonal antibodies. And we have to vaccinate all the patients with the meningococcal vaccine before we give these complement inhibitors. So I thank all the panelists and the audience for the patient listening. Thank you so much.
Well, firstly, let me compliment you for an excellent panel discussion of 2 cases.
Thank you, sir.
But once you were asking for the investigations, I could nowhere find the blood type, because
Yes,
it is actually the transfusion medicine department of the blood bank which picks up the cases of the autoimmune hemolytic anemias. Unfortunately, I didn't know, because what you said during your Pgi-Hem treatment, but that is a basic fundamental investigations. And actually there's a transfusion medicine or the blood center which picks up these cases and tells you, and they go along with that beaker or attending you. Hematology does not do it. And both, even monoclonal and Coombs test, is also
Blood
done
bank.
in the transfusion medicine department. Whether broad spectrum Coombs, monospecific Coombs, they will get. And then when you do the blood type, you have also to see that once you have doing a molecular typing has a very important role to see that in case there is any blood type which is clinically spent, the antigen is negative, you have to know it, because once you give the transfusion, you have to give an antigen negative for that, so that you know, immunize that patients for this, because that has a role in the treatment of such patients in the future, because you are using all high profile of the drugs which are costing in lakhs. But if you have immunized the patient, tomorrow he will have a problem in case he will have anemia and he needs a transfusion. And these type of things need to be reflected while you are making the discussion. But unfortunately, you are not picking up these things, you feel, and which actually I tell you, the hematologists or the clinical hematologists don't know these things. And this needs to be reflected. And I face a lot of problems once I discuss with the hematologist, and then they tell me, no, we are sorry, we have not reflected, and this needs to be. And that is why you need to have the discussion with the transfusion people and see, because I was asking Dr. Jain over here, do you do these things? Because we do all these things, but I don't know why it does not get reflected. So please take care of it.
Thank you, sir.
Good, Dr. That was fantastic. You
Thank you,
covered
sir.
everything, particularly warm antibody, autoimmune hemolytic anemia. Just a couple of points. One thing, I found the spelling of Coombs wrong in all the slides. Coombs was a big scientist. His spelling is C-O-M-B-S and not C-O-M-B apostrophe S.
Okay.
Please So that
Okay.
spelling was totally wrong.
Yes.
And secondly, as Dr. Makru was pointing out, blood group, what we do, see, blood transfusion forms the backbone of all things, as well as autoimmune. We have been managing autoimmune hemolytic anemia for the last 25 years. What we do, basically we will not get compatible blood. So RHKL phenotype forms one of the basic tests. So before he gets any transfusion, we need to do RHKL phenotype of that patient. And compatibility will be a problem at any level, every level of transfusion. So we give RHKL phenotype matched blood, which at least covers a lot of hemolysis. There's no problem with that. And particularly with CAD, another test is we can specifically identify the antibodies. Most of those cases have anti-P antibodies in them. So that can be just added. But excellent presentation.
Thank you, sir. And sir, one more thing, that majority of cases, as you have rightly mentioned, they are picked up because blood bank team calls us. There is a cross-match difficulty which is happening. So kindly suspect autoimmune. Yes, sir.
Actually, I have seen in the last 4 decades, it is the transfusion medicine
sir.
which picks up the autoimmune hemolytic anemias. And we tell them that you need, and actually in my hospital at Apollo Hospital, we do get involved in the treatment pattern of the patients. So, well, it is a win-win situations because there's a blood transfusion sometimes is a lifetime. I mean, life-saving procedure what we have to give. So we have to keep it in the mind. So that is very important.
Sir, another thing which I did not cover, I really apologize, was the allo antibody versus the auto antibody
Yes,
problem.
that is again, because you have to know, because these patients, and that is why I said, there is a possibility of an underlying alloantibody. Well, that is why once we say least incompatible blood, and you have to know what is that. So that is again, that's a topic in itself which can be discussed.
I think we have to stop here. You can later on discuss with Dr. Makru and Dr. Anand. And thank you very much for this panel discussion. It's of great importance to our young people who are handling autoimmune hemolytic anemia.
Thank you, ma'am.
Thank you very much. At the end of this session, I think I thank all the audience.
Thank you to all the speakers for the wonderful session, and I also thank the panelists and the chairpersons for chairing the session. Now we'll proceed for lunch, and we'll gather here at 1:45 for the next session on bleeding and thrombosis update. I request all the speakers post-lunch to please kindly submit their PPT in the preview room. Thank you.